Hey guys, so welcome to the next video on trigonometry. This video is a very important video because we are going to be talking about another unit of measurement of an angle called radians. So we are very used to understanding degrees. Degrees is the unit of angles that you have learned your entire life since elementary school, and this is the way that you've been trained to think. But in this lesson, we're going to try to teach another way of approaching angles and another way of writing angles in a different unit. So, radians is a very important unit because it is used in science and mathematics, and it's very important. It actually has a lot of meaning behind it. But for the scope of what we're learning right now, you just need to learn the differences and similarities between degrees and radians and establish a connection between the two so that you can convert between the two. So let's take a look at what a radian actually is. Okay, so here we have a full circle, okay? Notice that from the center to any point on the circle, that length is the radius. The radius is the measurement of distance from the center to any point on the circle. So let's call this here, the length of the radius, r. R will represent some value. It could be in inches, in feet, in centimeters, in miles, whatever unit you want to call it. Let's just say that this has r units of distance, okay? Again, the units here doesn't really matter. As you'll see, the circle can be bigger or smaller. This still here will be the length of the radius, okay? So instead of basing the measurement on 1 full revolution, we actually based the unit on the radius of the circle, hence the name of the unit. So essentially what we're going to do here is we're going to grab this radius here, and we want to trace an arc length across the circle whose length is exactly the same as the length of the radius. So that would be about here, I would say. So notice here, this arc length on the circle, this here is going to have the same exact, if you were to grab this and stretch it out, it would have the same length as the radius. So notice here that if the initial side is here on the origin, on the positive x-axis, and the terminal side traced an arc length that's the same length as the radius, this angle that we created here, yes, it does have some angle in degrees, and we'll talk about that later, but this here establishes what a radian is, because this here is called, this angle is going to be 1 radian. And that is the standard. Now, you can also shorthand, instead of having to write out the entire word radian, you could just say rad instead, and that represents the unit for radian. So here's the deal. Well, now how does this compare to the circle as a whole? So let's take this and break this apart. If now we're going to trade, here we have 1r. This is 1 radian. Now we're going to go here and notice that this is also 1 radian. And here, this is also another radian. So in total here we have 3 radians, okay? But there's a little bit of a problem. This is not completing the half revolution. This does not complete 180 degrees. So what's missing here? So notice we're missing a little piece here that's going to allow us to get to 180 degrees. So 3 radians and a little bit more will be 180 degrees. What is that little bit more? Well, it turns out that that little bit that's missing is 0.1415 ... This is actually an irrational number that continues forever. But does this look familiar? 3 radians and 0.1415. Does that not sound a little bit familiar to you? And it should, because it turns out that half a revolution is pi radians. Now again, pi is not some random letter that comes out of nowhere. Pi just represents a number. Don't let that symbol scare you off. Remember that pi just represents 3.1415, blah, blah, blah. It continues forever. It's an irrational number, but that represents 3.1415. So if you were to fit pi, an arc length that is 3 radians of length, that angle formed is pi radians, and notice that that forms 180 degrees, or half a revolution. Therefore, if pi radians makes up half a revolution, 2 pi radians makes up 1 full revolution. And this here is the most important concept in all of trigonometry and understanding radians and degrees. To understand that 2 pi radians is 1 full revolution, which is 360 degrees. So may seem a little intimidating again at first, but you'll get the hang of this in no time. So we've established here that 2 pi radians, which again, if pi scares you a little bit, just think of it as 2 times 3.1415. This is approximately 6.283 radians. Okay, again, but don't use this. We say 2 pi radians. This is equal to 1 full revolution. And this is, again, a different unit. And then 360 degrees, we also know, is 1 full revolution. Therefore, the established relationship between degrees and radians is that, and I'm going to write it up here, 360 degrees is equal to 2 pi radians. This here is the most important concept to understand. This ties together the 2 units of degrees and radians. And from here we can establish a conversion between the 2 units. Now again, these are 2 different units. This is degrees, this is radians. It's the same thing as feet and inches. There's a relationship between the 2, and they both measure distance, but 1 foot is 12 inches. They both measure the same thing, and 1 foot is equal to 12 inches, but they're 2 different units. So that is the same thing as 360 degrees being 2 pi radians. They both measure angles, but they are 2 different units. Before we continue any further, I want to talk about these angles here in degrees. These angles are some of the most important angles to know, especially in non-calculator problems. These angles are the main angles to understand in all of trigonometry. Although we've seen before we have a lot of different angles we can work with, these kind of form the basis of easy to solve problems that don't require calculators necessarily. If we talk about any other crazy angles, that's going to require the use of a calculator. But these angles are very simple to understand. So let's think about it. Here, I just want to break these angles apart so you could see where they come from and how they're useful. So, like I mentioned before, angles are always going to be talked about in standard position in this class. So we have our initial side here, and our terminal side rotates counterclockwise because we're dealing with positive angles here. Same thing applies if you went clockwise, but you'd be dealing with the negative angles instead. So, like we said before, if the initial side has not moved at all, we have 0 degrees. There's no angle that's been formed because the initial side and terminal side are the same. There's no angle measured between the two. Now, one full revolution. So if the terminal side rotated and went right back to the initial side, we get 360 degrees, which, as we said before, is 0 degrees. And 0 and 360 are coterminal angles because the terminal side ends up in the same place both times. Now, half a revolution, half of 360 is 180 degrees. So 180 is 1/2 of a revolution. Half of 180 is 90 degrees. And 90 degrees, if you think about it, is 1/4 of a revolution. Okay? Now, another thing, here we broke 180 degrees in half. We could also break 180 into thirds if we wanted to. So if this here is 180 degrees, then if we broke this into thirds, notice here, this angle here would be 60 degrees. So 60 is 1/3 of 180, which ends up being actually 1/6 of a revolution. So 360 is 1 revolution, 180 is half of that, is half a revolution, 90 is 1/4, 60 degrees is 1/6 of a revolution, because again, notice we could fit 360 degrees into half a revolution, so we could fit 660 degrees. If you think about it, 6 times 60 is 360. So that's another important one to understand. Another angle that we deal with a lot is, how about half of 90? So if we cut 90 in half, that gives us 45 degrees. And if you think about it, 45 degrees, you can fit 8 of these. So 8 times 45 is 360. So 45 is 1/8 of a revolution. And the last angle that we deal with is 30 degrees. Think about it like this. If we have 90 degrees, if you cut 90 degrees in thirds, well, this here is 30 degrees. 30 degrees is 1/3 of 90. So that essentially makes 1/12 of a full revolution. So these angles are very important. 270 is also important, but you could think about that as 3/4 of a revolution. So if you think about it, actually 0, the angles 0, 90, 180, 270, and 360, these angles break the revolution up into quadrants. So you remember 0 to 90 is the first quadrant, 90 to 180 is the second, 180 to 270 is the third quadrant, and 270 to 360 is the fourth quadrant. And then these are sub-angles that can break each quadrant up even further. So these are very important and they are used a lot. So, so now let's show here the conversion between degrees and radians. So it's pretty easy once we get the hang of it. 0 degrees, as we saw before, the terminal side has not moved at all, therefore there's no angle. So just like in degrees, there is 0 radians. Okay? The established relationship that we saw a little earlier was that 1 full revolution, which is 360 degrees, is 2 pi radians. Or, as we said before, about 6, a little bit more than 6 radians. But again, you just say 2 pi radians instead. So here, that's 1 full revolution. And from here on out, the rest is super simple. So half of 360 is 180. Therefore, half of 2 pi is pi. Half of 180 is 90. So half of pi is pi divided by 2. You just leave it like that. Now, what's half of 90? Half of 90 is 45. So what's half of pi over 2? Well, pi over 2 divided by 2, this is actually pi over 4. So, this is pi over 4 radians. How about the others? Well, we said 30 degrees was a third of 90. So, if we get pi over 2 radians, which is a quarter revolution, which is 90 degrees, and we divide that into thirds, again, 90 divided by 3 is 30, therefore pi over 2 divided by 3 is going to be pi over 6. So this is pi over 6 radians. 60 degrees, that was actually a third of 180. Well, so if 180 is pi radians, a third of pi radians is pi over 3 radians. Now 270, why don't you pause the video and try to solve this on your own. See if you could figure out what 270 degrees is in radians. So pause it. When you turn it back on, I will put the answer up for you. So if you got 3 pi over 2 radians, great job. So where does 3 pi over 2 come from? Well, you could think about it as pi over 2 radians is 90 degrees. 270 is really 90 degrees 3 times. So 3 times pi over 2. So pi over 2 plus pi over 2 plus pi over 2, that creates 3 pi over 2. You could also think of it as 270 is 3/4 of a full revolution. So if you do 2 pi times 3/4, that simplifies also to 3 pi over 2. So there's many different ways of thinking about this. I think the best way to think 3 pi over 2 is it's 3 times 90 degrees. 3 times pi over 2. See, 3 times pi over 2, that is 3 pi over 2. See? So it's 90 degrees 3 times, and that gives us 270 degrees. So notice that's very easy to establish the relationship between degrees and radians, because it's the same ratio. If you divide 360 in half, you also divide 2 pi in half, and you get 180 degrees or pi radians, and that represents half a revolution. So it's very easy to establish this pattern. Now I'm going to tell you something. I think it's very important to memorize this table, to let these conversions become part of who you are, so that you don't have to convert between the two all the time. They should come to your mind very easily. So again, if you understand 360 degrees is pi radians, the rest is really easy. A little trick to help you with these angles here. 45 degrees is pi over 4 radians. I see the 4 there, so I think that makes it pretty easy. You got the 4 and the 45 and the 4 down here in the radians. Now with the 30 and 60, a lot of people tend to confuse these, and when they see 30 degrees, they think pi over 3, and when they see 60 degrees, they think pi over 6. But don't get that confused. My trick, the way I've always memorized it, is to just switch the numbers. So when you see 30, think of 6 instead. When you see 60, think of 3. So like kind of like flip it. I know the intuition is to say that 30 is pi over 3, but just flip it. In your mind, try to flip it. That's kind of the way that I've always imagined, or how I've always helped myself memorize those angles. So they're very easy to memorize, so I suggest you put some time into knowing these conversions. And they're going to be important for the next video, which is going to show some tricks to solving problems involving radians and degrees a lot faster. A lot of the problems you're going to see are going to involve converting between degrees and radians, because again, they're both units of measurement. So just like you hear 24 inches is 2 feet, you have to be able to kind of think the same way in terms of degrees and radians. You have to understand how to convert between the two units without much hesitation. At the beginning, it's going to seem a little intimidating, and there's a very intuitive way of solving these problems if you understand ratios. I'm going to teach that method first because I think it's the most important, to actually understand what you're doing and why you're doing it. However, there is a pattern that leads to a formula that you can use, and I will show you guys the formula afterwards. But I hope that you guys put some time into understanding how to actually solve this mathematically and logically. And it involves the concept of ratios. Again, we've established here that 360 degrees is 2 pi radians. Now, to make the math a little bit easier, this relationship, there's an easier one to use that doesn't involve any fractions, but has a little bit smaller numbers. And that would be that 180 degrees is pi radians. It's the same thing. Again, half of 360 is 180, so half of 2 pi is pi. So I would say focus on this relationship, because notice it doesn't have any fractions, and it's the smallest numbers that we can work with without going to fractions. So let's deal with this relationship here. This is going to be the most useful. So let's do the first question. What is 120 degrees in radians? Okay, so our goal here is to express 120 degrees in terms of radians instead of degrees. So what I'm going to do here is set up a ratio. So I know that pi radians is 180 degrees. So I've established a known relationship between radians and degrees. So how many radians are in 120 degrees? So notice here we've established a ratio. Radians is to degrees. This many radians is to this many degrees, as this many radians is to this many degrees. This ratio now allows us to cross multiply to solve for our unknown value. So I could have written this in the other order. I could have put 180 degrees as to pi radians, and then we would have had degrees in the numerator instead. It doesn't matter. You would get the same answer regardless. The whole concept here is to set up a ratio where radians and degrees are in the same side, or either both top or both bottom. So to solve this, let's go ahead and cross multiply. So pi times 120, we get 120 degrees times pi radians equals unknown radians times 180 degrees. So if we want to solve for the unknown radians, we're going to have to divide by 180 degrees, both sides. Now notice the unit degrees cancels, so we're left with our unknown radians is 120 pi over 180 radians. Okay? Now, even though technically this is the correct answer, you do need to simplify. You have to give your answer in a simplified version. So 120 over 180 simplifies to 2 pi over 3 radians. So this here is 120 degrees in radians instead. Notice how I use the ratios to solve this. So given any degree, you really just set up this ratio and you cross multiply and simplify the fraction. Now, let's do another. What is 20 degrees in radians? You see, we're going to use the same exact ratio to solve this problem. Pi radians is to 180 degrees. Again, you could have done 180 over pi. Does it make a difference? As how many radians is to 20 degrees? So now you can cross multiply. So we would end up getting 20 degrees times pi radians equals question mark radians times 180 degrees. We divide 180 both sides. Notice the unit degrees cancels, and we're left with question mark radians is equal to 20 pi over 180 radians, which simplifies to pi over 9 radians. And that is our final answer. So 20 degrees is pi over 9. And you could also think about this as a shortcut if you want to, that 20 degrees is a ninth of 180 degrees, which makes sense here, right? 1/9 of 180 degrees of half a revolution, pi over 9 radians. It's the same thing. That's another way to think about it, and we'll talk more about those type of tricks in the next video. But notice here, again, we use ratios to solve this, but notice we did the same thing for both of these cases. In both cases, we multiplied by pi and divided by 180. In this case, we multiplied by pi and divided by 180 to the original angle, to the original 120. Here, from the first problem, we multiplied by pi divided by 180. Here, for the 20 degrees, we multiplied by pi and divided by 180. Notice that relationship. So that establishes this, this formula here. If we wanted to go from degrees to radians, we're going to multiply our angle in degrees by pi divided by 180 degrees. Okay? Because notice, it doesn't matter what the angle in degrees would have been, you would have done the same exact thing. You would have multiplied by pi and divided by 180. And that's the rule for converting. Multiply by pi, divide by 180. Now let's focus on converting radians to degrees. So for first question here, what is pi over 7 radians in degrees? So once again, we set up a ratio, and it's your choice what you want to do first. But I would just say here, well, pi radians is to 180 degrees. Again, if you feel better saying 180 is to pi, that's fine. You'll get the same result. But just remember here, since radians is in the numerator, radians always goes in the numerator. So if pi radians is to 180 degrees, pi over 7 radians is to how many degrees? So we go ahead here, we cross multiply. So we're going to do pi over 7 radians times 180 degrees is equal to pi radians times question mark degrees. So we want to solve for question mark degrees, so we divide by pi radians, both sides. Notice the unit radians cancels. So we're left with pi divided by 7 times 180 degrees divided by pi. And this is question mark radians. Notice the pi here will happen to cancel out, and 180 divided by 7 is equal to 25.714 degrees. So this here would be this would be pi over 7 radians in degrees. Let's do another problem here. What is three pi over 5 radians in degrees? So I'm going to erase this work here, but you're going to notice a little pattern here. So pi radians is to 180 degrees, as 3 pi over 5 radians is to how many degrees? So once again, we cross multiply. So we want to divide by pi radians. Notice the unit radians cancels. So we're left with question mark degrees is 3 pi over 5 times 180 divided by pi radians. Because this is multiplying, it doesn't really matter. I just split this up so I don't have such a big complicated fraction. So I just put the pi under 180 here to keep it simple. Now notice that the pi's cancel, so you're left with, the unit radian cancels as well. So we're left with 3 over 5 times 180, which simplifies to 108 degrees. Okay? So notice in both times, we multiplied by 180 and then divided by pi. If you rewind the video, you'll see we did the same thing with the other problem. So this establishes like a shortcut method, which is if you want to convert from radians to degrees easily, all you have to do is get your angle in radians and multiply by 180 degrees over pi radians. Because notice, no matter what the angle in radians would have been, you would have always multiplied by 180 and divided by radians. Okay. Now, these two here, these are the formulas to convert between degrees to radians and radians to degrees. Again, if you ever forget these, you can always solve the problems using ratios. But knowing these rules speeds it up and lets you solve these problems a lot quicker. Now, if you ever get confused between the two, the way I always remember is I want the units to cancel out. Because again, if I have an angle in degrees and I want the answer to be in radians, I want the units degrees to cancel out. So notice if 180 is in the denominator, degrees will cancel, and you're left with your answer in radians. Here, if you're given your angle in radians and you want to convert it to degrees, I want the unit radians to cancel. So notice how radians is in the denominator, and it will cancel. Okay, so that's kind of my trick to kind of helping you memorize this rule a lot faster. So if you understand these conversions here, and all you have to do is multiply by pi over 180 to convert from degrees to radians, and 180 divided by pi to get from radians to degrees, converting between the two units will be very, very easy. Okay, so here are a few problems. The first few problems are, I'm giving you degrees and I want these degrees given as radians instead. Same angle measure, but in the units of radians instead of degrees. And with these, I'm giving you the angle measure in radians, and I want the equivalent angle measure in degrees instead. So using whichever method you want, either setting up the ratios and solving it, or just using the shortcut formulas, go ahead and convert these units. And remember, simplify them as much as possible. So go ahead, pause the video, do the problems on your own, and when you press play, the answers should come up in a few seconds. And there you have it. These are the final answers. So notice the 30 degrees and the pi over 4 radians, those no need to convert. These, if you remember earlier, are angles that you need to have memorized and know them like the back of your hand. But if you went ahead and used the formulas or converted them using ratios, you'll notice you're going to get the same answer regardless. The only other tricky ones were the pi degrees and the 1 radian. So pi degrees, that's a very tiny angle if you think about it. Pi degrees is 3.1415 degrees. It's a very small angle. And this is how it would look like in radians. And 1 radian, I told you we'd come back to this. Remember, 1 radian is the angle formed where the arc length is the same as the radius. So we end up getting that is 180 over pi degrees, which if you use a calculator to calculate that, we would get that that's essentially 57.296 degrees approximately, which looks about right. So that is how you convert between degrees and radians. So go ahead, rewatch the video, and this is a little bit new, and I know it's going to require some practice, but just go continue drilling, find practice problems online if you need to, and find other videos. There are lots of very good videos that can help you even more if you need it. So good luck and see you guys later. Bye.